We are facing a challenge. Aalto University Properties is the largest real estate owner in Otaniemi, Finland, the home of Aalto University. Aalto University is a multidisciplinary scientific and art community working in the fields of technology, business and art. At the moment, the Otaniemi area is facing a fundamental watershed. In the next 20 years, over 450,000 square meters of new buildings will be constructed. Over 10,000 new people will be living and working there. And when this is done, the goal is for Otaniemi to be energy self-sufficient. So right now, it is time to create the tools for this enormous task. Open Energy Site ae5 is a tool for increasing energy efficiency and local energy production. It combines different data formats and data sources in a comprehensive manner to be processed in one place. It enables data utilization and data distribution. Open data is available to everyone. It creates an opportunity for a comprehensive energy solution in the design of the future society. The approach is scalable and transferable to any location. It creates competition for energy production on a local level. Over time, quantitatively and qualitatively. Let's see how the system would work. The solar and geothermal energy potentials are visible on the map. These potentials are based on the city of Espoo's energy maps. The area of the city of Espoo is laser scanned regularly from an airplane. The solar irradiation simulation is based on a three-dimensional model created using this laser scanning data from 2012. The three-dimensional model is used together with a full year, hour-by-hour weather simulation of a standardized reference year. This simulation method is able to take into consideration the sun's path during the year, shape and orientation of all the rooftops, changes in the cloud coverage and humidity, and shadowing effect of the other buildings and the vegetation and plants. The city has estimated geothermal potential by using city soil maps and bedrock data from the Geological Survey of Finland. From this starting point, it is easy to start planning a solution that takes into account the energy demand and use, energy sources and production, as well as energy distribution and storage. Now, these 5 buildings have been selected and a new building has been added. As an example, we have chosen here an optimal location for a geothermal heating unit. Here you can see the current energy consumption status. For example, you can see basic information for the building, for example the address, the size, and the energy class. You can also add the target for the new building. The tool combines the energy information of the selected 5 buildings. It seems like something could be done to improve the energy efficiency of the buildings. The design tool contains important aspects of information. Solutions for energy production, energy usage information, and energy audit information of the building. In this phase, we will design and decide the energy solution for the selected 5 buildings. As we can see, solar energy and geothermal heat could be possible solutions. There are also a number of building improvements that would help conserve energy. It is also possible to plan the future use of the building. Based on the development of the building portfolio, we can estimate the energy consumption and the cumulative costs. Consumption and cost information are based on the choices made in the designing phase. With these solutions, we can lower the consumption significantly. Based on the costs, we can estimate that the investment would break even in about 10 years. Furthermore, the energy balances are based on the choices made in the designing phase and when selecting the 5 buildings. The energy balances for electricity, heating and cooling show that the buildings would be quite self-sufficient in power and heat. If the balance does not meet expectations, we can redesign the energy solution by changing the selection of the energy production types. With the decisions made in the designing phase and selection of these 5 buildings, the tool provides a concrete calculation for decision-making. It is also easy to add different scenarios and compare them with each other by playing around with alternative solutions. Can all this be done? Sure. All the data is already available, mostly open source. Also, the central components for the calculations already exist, open source. A strong case can be made in terms of business operations. Aalto University Properties' existing energy bill alone is 6 million euros every year. There is room for improvement. Aalto University Properties is the critical mass in the area. It is easy to persuade the other players to join. Everyone shares the benefits. Otaniemi and Aalto University is the ideal environment for new technology. There's a direct connection with teaching, research, development, and innovation. What does all this mean for us, the building owner? The tool provides information to guide decisions about where and when to invest. It also enables better life cycle energy management and provides better insight for long-term solutions. We can see that the tool provides information to the building user on how to influence energy costs. This encourages future investments in user-centered solutions. Furthermore, we can see that through the Open Energy site, we can also renew the energy market. The tool enables the implementation of integrated and decentralized solutions in the built environment.